Welcome back, and here we go for our final segment. We're going to look at bicycloalkanes. Clearly, they have more than one ring. These big dots here, sadly, they won't be on the test. So the first one on a test would be drawn like this. You have to decide where those dots are. Those dots are important. And I'll do the third one as well. It's a little tricky, isn't it? There we go, first and third. How do you decide where the dots are and what are they called? The dots are called bridgeheads, and bridgehead carbons. Bridgehead carbons are shared by all possible rings. There are always two of them. And let's look at our two examples. And here we go. And make it. I'm just putting dots everywhere. Dot happy here. And we'll put our bridgehead carbons in blue. And let me count all the ways. It doesn't like me doing dots like this. Okay. Let me outline it. You can do bridgehead to bridgehead in this ring, 6. Bridgehead to bridgehead in this ring, 5. And include both bridgeheads going all the way around the outside for a third possible ring. Okay. Same story here. You can do both carbons included in this ring, 5, both included in this ring size, 7, and both in this ring size, that's 9. 8, sorry. 6 plus 2, 8, going around the outside. Doesn't matter how big it is. Those are the bridgehead carbons. Now, rules of nomenclature, I'm going to do some editing on these two structures. Okay, maybe I'm not. There, I put a group on there. And I'll put a group on this one too. Okay, you have new rules. Bicyclo, first off, you identify it's bicyclo by looking at it and seeing more than one ring. You say, those are bicyclos. They have their own rigid molecules with rigid rules. If you tried to make a toy of these, and I'm going to bring my toys home tomorrow so I can show you on the screen. This is going to be a new adventure for everybody. Putting toys up, big camera. The rules of nomenclature for bicyclo, they're rules that take over. You have two choices for carbon 1. It's 1, and then if you chose that to be 1, you've got to go in the biggest ring for 2. 2, there's a new rule, isn't it? So one of the bridgeheads is number 1. Carbon 2, no choices. You got to go to the biggest ring, 2. And I'm liking the green choice of numbering. And that would go to 6 here. And in the red numbering, if you went 1 here, sorry, we already had a 1 there. Let's not do that again. 1 down here, and biggest ring next. And red puts a group on 5. Green puts the group on 2. Don't like the red. Green wins. And there's always 3 ways to get from one dot to the other. One dot to the other. What are the name of our dot carbons? They're called bridgehead carbons. The computer's giving me a hard time. Sorry. There. So one of them must be number 1. That's a rule. And then you follow your other rules. If we were to continue our numbering on here, we went for green, which was the better way. 1, 2, 3, 4, 5, 6, 7 would be here, attached to 6. Let's put this off in a little box area here. This was just deciding which direction to go. Yeah. Okay. Want to move my box? I can't even. There we go. Now, in this example here, you can't violate the bicyclic rules. So the green is going to win here for a different reason. For 7, you don't go here for 7. Don't do that. No. After you do the biggest ring, you do the second biggest ring. Oh, I don't like green all of a sudden. The other possibility, the only other possibility, is to start 1 here. Go to the biggest ring for 2. And that goes 6 up here and 7. So now your choices are the red 7 is a winner compared to the green 8. For the reason we discussed right at the beginning of today's lecture, it's a smaller number. And that'd be 7 propyl. Let's finish the names off on these two. Green 2 has an ethyl on it. And it's a bicyclo molecule. So after the groups, we go bicyclo, and we always need 3 numbers. The numbers will go largest to smallest. Largest, dot, middle. Yeah, that's a dot. Doesn't look like a dot. Those dots are important. I can't do dots. Smallest. Can you remember those dots in the name are actually the carbons? It does not like me just trying to make a big dot. Okay. Those are the bicyclic bridgeheads. They count in the name as dots. And let's go over here. I want to count from 1 to 6 in the biggest ring, but I do not want to count 1 and 6. Don't count them. Otherwise, you're counting the bridgeheads over and over, and we know nomenclature never counts a carbon more than once. So the question is, how do you get in the biggest ring from 1 to 6? How many extra carbons do you need? Because you're not counting 1 and 6. So here we go. It takes 1, 2, 3, 4 more carbons to get from 1 to 6. Now, we're going to go from 6 back to 1 or 1 to 6 this way. I don't care how you call it. Just do it. How many extra carbons to get from this dot to this dot going in the next biggest ring, which is there? 3 extra carbons. I know, we're running out of time, but we're almost there. And now the easiest way, which is the shortest, which goes last, from 1 to 6, how many carbons in between? Absolutely none. Tell me that. 0. And this may surprise you. The name ends with nonane. I knew that without even counting the carbons. I do it this way to verify that I did the rules right. 4 plus 3 plus 0 is 7, and the dots each are 1 carbon. They're called the bridgeheads. 8, 9. Nice. So 2-ethyl bicyclo 430 nonane. And there's the bicyclo 430 nonane because there's no group on it. Let's get her done. This one over here, we like the red system for the propyl. So I'm going to put the name right underneath of it. 7. Propyl. And that's the only group. It's a bicyclo again. And I know I see the name above it, but let's go through the steps again. We need the 2 dots. Should be able to do that and that. Now I got dots. All right. From 1 to 6 without counting 1 and 6 is 4 again. What color are those? Those are blue. That looks like a Y. Going around the next biggest ring, don't go in the middle. That's only 1. Next biggest ring has 2 more carbons. 4.2. Now my dots are too big. I'm sorry. And then there's 1 more carbon in between 1 and 6 this way. Add 4 plus 2 plus 1 plus 2 dots, and you get nonane again. 7 plus 2. And I will leave it up to you to verify that I used the correct numbering system up here, as opposed to starting your homework assignment is with you're going to put an X on it. The biggest bridge is in the middle this time, which would mean 7, 8, 9, 8, 9 here. This is not the right way to go, because the next biggest bridge would be on the bottom. 1, 2, 3, 4, 5, 6 versus on the top 1, 2, 3, 4, 5. So yeah, that would make this the 10. And you wouldn't hit a group. I know we got to end here. 10, 11, 12, 13, 14, 15. If I'm going that way, 15, where's your 16? Well, you can't use a number that's been used. That would be 16, 17, 18, 19, 20. 20 is not as low as 16. 20 is bad. 16 is good. That ends this segment. And if I put 2 groups on these things, you would know how to do cis and trans, because that's just the wedges and dashes, okay? So please look at nomenclature over the next couple days and get into the rest of chapter 2. Try to have it read by Wednesday. And I will see you then. Adios.